Greetings and welcome to Week 2, Unit 5 related to Professional Core and Professional Elective courses. In the previous unit, we understood the nature and role of basic sciences and engineering sciences in engineering programs. Now, in this unit, we'll try to understand the nature and structure of Professional Core and Professional Elective courses. The basic requirement is an engineering student should attain program outcomes identified by the NBA and program-specific outcomes chosen by the department. Professional core courses are decided by the PSOs, that is, program-specific outcomes. If the PSOs change, the professional core courses will have to be altered correspondingly. So, in the top-down design of a curriculum, POs and PSOs decide the curriculum. POs are given by the NBA, PSOs are decided by the department. Now, PSOs for any branch of engineering, any program, need not be identical. Each department can choose how it wants to, where it wants to specialize, where it wants to give more emphasis. Okay, so PSOs should reflect that. Here we are giving two samples. First one is specify, design, prototype and test modern electronic systems that perform analog and digital processing functions. See, there are four action verbs: specification, designing, prototyping and testing, and that to modern electronic systems that perform analog and digital processing functions. That means the entire electronics is captured in one sentence. Then we talk about PSO2, architect, partition and select appropriate technologies for the implementation of a specified communication system. So here we are not designing or prototyping, but we are architecting, partitioning and select appropriate technologies for that means the student should be trained to architect a communication system. Then PSO3 is design essential elements of modern RF and wireless communication systems. So here the third PSO is related to designing elements of RF and wireless communication systems, that is circuits and antennas. So there is a lot more emphasis on communication and its hardware as well. Whereas if you go to the sample 2, the PSO1 specify, design, prototype and test electronic systems that perform analog and digital signal processing functions as per user requirements using currently available electronic components. The sample 2 now talks about the same, similar to PSO1, except it emphasizes you should be able to do that with currently available electronic components. That is what is used in the market, or you can say what the industry uses now. And then further we are also putting another PSO related to electronics: specify, design and test power supplies for electronic systems including battery management and power amplifiers using currently available electronic components. Once again, the focus is on electronic components. This is where the textbooks can mislead you. If you go to a textbook, they may be using legacy components rather than the currently available electronic components. The third one, PSO3, architect, partition and select appropriate technologies to implement a specified wired and wireless communication system. So we are not talking about, unlike sample 1, we are not talking about designing essential elements of a communication system. That is kind of kept aside. Okay. So as you can see, there is no a department will have to select. In fact, they can write another combination of three PSOs if they want to further modify that. But these two PSOs are different, both are acceptable. And you have to design your core courses according to the selected sample. Okay, now let us proceed. Planning for professional core courses. The core courses for these two sets of PSOs will be different. Sample 1 gives more emphasis to communication system. Sample 2 gives more emphasis to electronics. Both are justifiable. As there are two streams in ECE, the starting point can be 25 credits each for electronics and communication. You have two streams, both we consider equally important. So what do? We start with out of 50 credits. These 50 credits are after engineering science courses are already taken care of. That is different. That set is different. These are over and above the chosen engineering science courses. So start with 25 each, and then as you finalize that, they may slightly differ from 25, but total will have to be 50. And some of the guidelines that you need to follow in selecting this, the interdependence among these courses should be carefully built in, because no course at the lower level should hang by itself. It should be a prerequisite to some course at a later stage. Repetitions among the courses should be avoided, because the number of credits now is a bit less compared to the earlier practices. You have to ensure that you are not having repetitions between courses. And it cannot, the many times students say we have not understood in the previous course, and they make the faculty member repeat what has been taught in the earlier course. That kind of thing is not acceptable. Courses should be well connected. The connections can be captured diagrammatically by using a CMAP tool. PSO in sample 2, PSO sample 2 will require at least one extra course than sample 1 in electronics. In view of the present state of affairs, courses need to be designed not on available textbooks, because we have to shuffle the topics to make sure that we are within the limit of number of credits. So you may have to pick topics what you want to teach as important. There may not be a particular textbook for that. There may be a combination of books that can be used, but sometimes it is not. But courtesy current information that is available on the net, either using AI tools or otherwise, we have plenty of information available on the line, and any faculty member can synthesize the total amount of information required for his course from the internet, and that can be made available on the web to the students as well. Okay. Now, for sample 1, what we just showing the mutual dependence. Now, here the ones in the green are already taken care under the category of engineering sciences, and actually the engineering product design is a common course for all branches. So you start with that, and then you have one course on analog circuits and systems, and then this is a prerequisite to mixed signal circuits and interfacing, which is predominantly related to ADCs, DACs, and so on. And then the other branch is basics of digital systems, microcontrollers or microprocessors, whatever name you want to give. That can lead to embedded systems. But embedded system, when you talk about any application, you may want to use some digital signal processing data. And then analog circuits will also lead to, though this course is not very popular, not currently, at least many of the electronic faculty are not trained in this, but microelectronic systems packaging, knowledge of that is necessary for any electronic engineer, because an electronic circuit while you design a circuit with components, electronic components interconnected, but in actuality, these components have to be mounted on a substrata. That substrata is generally a printed circuit board. That means the components are interconnected through copper lines from one component to the other. And, and in today's context, the footprint of each circuit will have to be reduced as much as possible. And also, as the components operate at a very high frequencies, then the even though it is very small interconnection between components, that can distort the signals. So you have to ensure that the signals are not distorted, and each component will dissipate some amount of electrical heat, and that heat to be removed. So there is a thermal dimension of any electronic product. Though you are not becoming a specialist by one course here, at least electronic engineer should be aware of all the issues involved in that. Physical size, the interconnections, and when the lines are very close to one another, there is electromagnetic interference as well. And so electromagnetic compatibility will have to be taken care of, and thermal issues have to be resolved. So at least you should be able to communicate or interact with specialists in this area. So that's why first level course on microelectronic systems packaging we consider necessary. And both of them will lead to electronic product design. And this can be actual, what do you call, it can be the final product itself. That is, your project can be, this can be your project. So it leads to electronic product design. So it may not be a course, but these are the courses that we consider required for this. Okay. Now let us look at PSO sample 2. You now add an extra course here. Power supplies and power amplifiers, or whatever you want to call it. Power supplies and battery management, and also include power amplifiers as required. Okay. So the scope can be very, very large here. So one has to be careful with this. Maybe a 2:0:1 course will meet at least first level requirement. So the core courses for sample 2 will be different for electronics. Now let us look at core courses in communication. These can be considered, I am only creating 8 into roughly 3, it will become 24 approximately, and maybe 1 or 2 will have a lab as well. So here the core courses are analog communication systems, digital communication systems, data communications and computer networks, information theory and coding, wireless communication fundamentals, mobile and cellular communication systems, RF and microwave communication, antennas and wave propagation. This set of 8 courses is again is not the final version. Depending on whether you are going to the sample 1 or sample 2, this list can be slightly modified. That is left to the department. Okay, now as you can see, those courses are also captured here along with the electronics one. This will be for sample 2, and as you can see, there is no direct interaction between the two. Unless the electronic product happens to be related to communication, then all this information will again be useful for that. Though I have not shown that kind of interaction here, but these are the courses and their relationships shown as a diagram here. So this is still, I have not put the number of credits here. That requires a little more what do you call, careful iterations on this to make sure that you are within the 50 credit limit for the core. These are the core courses of ECE program. And for all other branches, you can do a similar one. For example, if you take mechanical, they have 3 streams. Here there are only 2. Mechanical will have a design, then you have thermal engineering, and then you have manufacturing. There are 3 streams. So you have to identify which are the core courses for each one. And if you take triple E program, electrical and electronics program, then instead of electronic you can pick from here, but the electrical courses will have to be correspondingly be added. There can be some interaction between them as well, especially in today's context. Whereas civil engineering will provide a little more difficulty. They have generally something like 5 streams. You have structures, hydraulics, and geotechnical engineering. Then you have what do you call it, environmental engineering, and so on. 4 to 5 streams you have. Then you have to carefully select your core courses, because to distribute under 5 streams will become a little more difficult. Okay. Now this is another sample. I'm not working out all the details. Here PSOs for computer science and engineering. These are 2 different sets of PSOs, and for each sample the actual number of the courses will be different. Now coming to professional electives. Professional electives can be offered in several ways. Multiple bouquets of courses, each leading to one specialization. You can have one bouquet of courses. Each bouquet, let us assume if you have 24 credits, let's say we give 3 credits for each course. So those 8 courses can be organized in such a way that a student specializes in that area. But if you want to give some more choice to the students, what you can do, you can make something like 5 courses compulsory, and 3 courses can be taken as soft core from that. In the sense, you give a choice of courses. So he will take compulsory 5 courses and chooses between the other list of courses, 3 of them. And then the third option is give a large list of courses, including NPTEL courses, and give a complete choice to the student to pick 24 credits from that. That if he wants to somehow do whatever he likes to do, then he will pick from 24 credits from that list. But of course, when you give that kind of choice, there can be issues related to timetabling and faculty availability. So it all depends on the situation. In what way you want to organize your professional electives. Now, let us look at electronics as we started with. Electronics bouquet can be design of digital ICs, design of analog ICs, power electronics. You call it power electronics, but all the things that you want to deal with the power can be incorporated into that. High frequency circuits, interconnections, embedded systems design and RTOS, ARM or FPGA based system design, and some application like medical electronics. If you don't like this, you can say automotive electronics. Okay, 8 courses, all of them are offered as 3:0:0 or 2:0:1. You can have a lab also associated with that. Now, communication bouquet, antenna theory and design, RF circuit design and measurements, microwave engineering, wireless communication and networks, optical communication systems, satellite communication, network protocols and architecture, Internet of Things communication. Of course, the selection will depend on, you can add many more courses to this list. Communication, there is no depth of courses. Finally, depending on the resources available to you, you select the sample set of the communication bouquet. Now, having given the same set of courses, you can also add another bouquet called signal processing bouquet. We have already done two signal processing courses. In signal processing, you have to worry about communication as well as any hardware implementation. So, to that extent, electronics and communication courses still become relevant. Core courses become relevant, but you can have a bouquet like this: advanced digital signal processing, image processing and computer vision, speech processing and recognition, multi-rate signal processing and wavelets, audio and multimedia systems, statistical signal processing, machine learning for signal processing and communications, deep learning for embedded vision. Those students who are interested in image or speech can or any audio multimedia systems, they can pick this signal processing bouquet. Okay, you club all them and make a list, and if you want, you can give a free choice to the students. Okay, this is how the number of credits will have to be respected. That is 50 for core courses and 24 for electives. That has been our suggestion. So please stay within that. It is possible to do so. The only thing is you will have all the freedom in the world when you don't tie yourself up to available textbooks. Still use textbooks as a resource material. Available books as a resource material, but not as textbooks. Textbook, by definition, that you will have to pick the chapters from the book given and only you have to stick to them. That is not on. Because generally, what happens with the textbooks is when somebody has offered a course in one particular way over several years, then that professor writes a textbook. By the time the textbook comes, in many cases already the material becomes slightly dated, especially in the area of electronics. So you are forced to start with something is already dated. So please don't do that. Whereas in the case of some of the electronic basic communication courses, some of them can be followed by standard textbooks, but not every course. So if you keep this in mind, you can design a currently relevant program in any area. Okay, I have given you only ECE as a sample because of my familiarity with that, whereas similar exercise will have to be done with regard to other branches. So in the next unit, we will try to understand nature and structure of projects and internships. And thank you very much for your attention.